Expressions that multiply to a given product are called factors of the product. And the process of splitting a product into factors is called factoring. So here we have two expressions, 3x plus 1 and 5x plus 14. And when we multiply them, we get this product. So 3x plus 1 and 5x plus 14, those binomials are the factors of that product. If we multiply it out, we're going from these binomial factors to this trinomial. But what we're going to be doing is we're going to be factoring. We're going to be given the product and we're going to be asked what these factors are. Okay, so there's a process for factoring trinomials, and here are the steps to that process. So factoring trinomials of the form ax squared plus bx plus c, where a, b, and c are the coefficients and x is the variable. So this is a second degree polynomial, and we're going to use trial and error. The first step is to write the trinomial in descending order of degrees as needed. The second step is to factor out any GCF. The third step is find all factor pairs of the first term. The fourth step is to find all factor pairs of the third term. The fifth step is to test all possible combinations of the factors until the correct product is found. And then lastly, you can check your answer with multiplication. So let's look at this example here. Factoring this trinomial. First thing, we want to put the trinomial in descending order of degrees as needed. But this is already in descending order of powers. I see x to the second goes first, x to the first is second, and x to the 0, where there is no x, is last. So it's already in descending order of powers. The next step, I want to factor out any GCF. Well, the only numerical factor common to 10, 43, and 12 is 1. And the smallest power of x is x to the 0, which is also 1. So the greatest common factor here is 1. Whenever the greatest common factor is 1, it means we're not going to have any monomial factors. So we can assume that we're going to get two binomial factors. So I'm going to be looking for two binomial factors. To find these binomial factors, we proceed to the third step. The third step is to find all the factors of the first term. So basically find all the factors of the leading term. And the factors of 10x squared, the linear factors, are x and 10x, because x times 10x gives you 10x squared. And another one would be 2x and 5x, because 2x times 5x also gives you 10x squared. So those are factors of the first term. I also want to find all the factors of the third term. So I need all the factors of the constant, 12. So I know I have 1 times 12 can give me 12. I know that 2 times 6 can give me 12. And I know that 3 times 4 can give me 12. So those are all the factors of 12. And once you have all the factors, the next thing we want to do is we want to try all the combinations of these factors. So basically the factors of 10x squared are going to be in the first positions in each of these binomials. And the factors of 12 are going to be in the second positions of both of these binomials. And we're going to try all the combinations until we find a product that when we FOIL it, we get this trinomial right here. So let's go ahead and try one of these pairs that give us 10x squared. Let's go ahead and try 2x and 5x. Let's go ahead, put the 2x and the 5x in the first positions here. And let's go ahead and try out the factors of 12 in the second position. So first, I'll start with 1 and 12. And because this is a plus sign, I'm going to use the same sign in both parentheses. And the sign I'm going to use is a plus sign. So whenever the constant is a positive number, you know you're going to be using the same sign in both parentheses. And the sign of the linear term, the second term, is the sign you're going to use in both parentheses. So in this case, I'm using the same sign. I'm using 2 plus signs in both of my parentheses. These are both going to be sums. Now I'm going to just try and see. I know that first times first works out. That'll give me the 10x squared. And I know that last times last, 1 times 12 will give me 12. So let's try outside outside. The product of the two outside terms gives me 2x times 12, which is 24x. And then I try the product of the inside terms, which is 5x times 1, which gives me 5x. And if I add those two together, can I get the middle term, 43? No, because 5x plus 24x is 29x. So that does not work. So we can switch the two numbers around. We can switch the 1 and the 12 and see if this one works out. But the issue here is that we already know that the greatest common factor of all three of these terms is 1. So that means both of my binomials will also have a GCF of 1. So this binomial I don't even have to use because that one contradicts a fact that I know that the GCF of this entire trinomial is 1. So the GCF of all its binomial factors has to also be 1. This binomial has a GCF of 2, so we don't even have to try it. So we'll move on. We know that the 1 and the 12 don't work with the 2x and the 5x. So now we'll move on and try the 2 and the 6. So we'll put the 2 and the 6 in here. But once again, I have the issue here. This binomial has a GCF of 2, and I know that my binomials need to have a GCF of 1. So that one won't work either. And let's try to switch them then. Let's switch the 2 and the 6. But when I switch them, I see this binomial once again has a GCF of 2. So as long as we know the GCF of the original trinomial is 1, each binomial we form should also have a GCF of 1. And if it doesn't, we don't even have to try that particular combination. So we'll move on to the next pair of numbers that give me 12, 3 and 4. So let's try 3 and 4 now. And in this case, I can try the outside product because I know first will give me 10x squared, and I know last 3 times 4 will give me 12. So let's try the outside product. 2x times 4 gives me 8x, and the inside product, 15x. That's 3 times 5x will give me 15x. When I try to add those to get 43, that doesn't work out because 15x plus 8x gives me 23x, not 43x. And I need 43. All right, so that does not work either. So I can switch them around maybe. Let's switch the 4 and the 3. And let's see if this works. But hold on. The GCF of each binomial needs to be 1, and this binomial has a GCF of 2. Therefore, I don't even have to try that orientation. That combination will not produce anything. So what I found is the 2x and the 5x don't work with 1 and 12. They don't work with 2 or 6. And they don't work with 3 or 4. So 2x and 5x is out the window. But there's still one last pair I can use to give me my 10x squared. I can try the x and the 10x. So now I'm going to try x and 10x and go through all the pairs of factors of 12 until I find a combination that can give me 43 in the middle. So let's go ahead. Let's see. So let's try it first with the 1 and the 12. But of course, with the 1 and the 12, the GCF of this binomial is not 1, it's 2. So I don't have to try that combination. So let's switch them around and see if that works. So I'll switch the 1 and the 12 around. And let me see. Now let's try it out. Outside product gives me x. X times 1 is just x. But the inside product gives me 120x. 120x is going to be added to x to give me 121x. But what I really need is I need 43x. So that does not work. So x and 10x does not work with 1 and 12. I move on to the next pair, the 2 and the 6. So putting in the 2 and the 6, I see I don't have to try it out because this has a greatest common factor of 2. And I know each binomial should have a GCF of 1 if the original trinomial has a GCF of 1. So that's not going to work. So let's switch them around. And even when I switch them, I see that that second binomial still has a GCF of 2. So that's not going to work either. So I'll move on to the 3 and the 4. This is the last chance. I'm trying the x and the 10x with the 3 and the 4. That's the last combination. So let's try 3 and 4. We'll put the 3 first and the 4 second. So we try the 3 and the 4. And that second binomial has a GCF of 2. So this isn't going to work. So let's try to switch the 3 and the 4 around. Switching around the 3 and the 4. I see, all right, the GCF in both binomials is 1. So let's try to check the outside products. That gives me 3x. The inside product, that gives me 40x. And 40x plus 3x gives me 43x. So the very last combination I tried was the one that worked. And that is the correct factorization. That is the factored form of 10x squared plus 43x plus 12. You can try it out. First times first gives you the 10x squared. Outside outside gives you 3x. Inside inside gives you 40x. 3x plus 40x gives you 43x. And last times last, 4 times 3 gives you 12. All right, so that's how you factor a trinomial using the process of trial and error. Let's look at another example. So here's another example here. Factor the trinomial 3x squared plus 10x minus 8. Let's go through the process. First, we put it in descending order of degrees. It's already in descending order. 2, 1, 0 are the degrees of those terms. And then you try to factor out the GCF. But in this case, the GCF of 3, 10, and 8 is 1. That's the largest factor of all three of those. And this last term is a constant. It doesn't have a variable. So the GCF is 1. Since the GCF is 1, I can assume there are no monomial factors. So I'm going to look for some binomials as factors. To find these binomials, I know that the first terms in the binomials have to be factors of the leading term here. So I need to find factors of the first term. Well, the factors of 3x squared are just x and 3x because 3 is a prime number. I also need to find the factors of the constant because those are going to be the factors, or those are going to be the second terms in these binomials. So I need to know what the second terms are going to look like. And it turns out the factors of 8 are either 1 and 8 because 1 times 8 gives you 8, or 2 and 4 because 2 times 4 also gives you 8. Here we're ignoring the sign. The sign is negative until we go to populate the binomials here. When we go to try all the combinations, we're going to take into consideration the fact that the 8 is negative, which tells me that, for instance, when I put the x and the 3x in here, one of these is going to be a sum of 2 terms, and the other one is going to be a difference of 2 terms. So one of them is going to be a subtraction, the other one is going to be an addition. So when I use the 1 and the 8, one of them has to be negative and the other one positive. They have to have opposite signs because the constant is negative. So anytime you have a negative constant, you know that you'll have 2 opposite signs, or one sum and one difference for your binomials. So your binomials will have opposite signs in the middle of them. We try these out. The outside product will give me 8x, x times 8, and the inside product will give me negative 3x. When you add those together, you get 5x, not 10x. Even if we were to switch the order of these, so instead of negative 1 over here and 8 over here, we just switch them around. When we tried this out, the outside product would give me negative x. The inside product would give me 24x. And when I add those together, I get 23x. 23x is not 10x. Therefore, this combination doesn't work. So x and 3x does not work with 1 and 8. The next thing we're going to try is we're going to try it with the 2 and the 4. The outside product here is going to be 4x. The inside product is going to be negative 6x. And when I combine those, I get negative 2x when I add those. We needed a 10x. And negative 2x is not 10x. Even if I were to switch the signs and make this positive 2 and this negative 4 instead, so even if I switch the signs around, I still get outside product to be negative 4x, inside product to be positive 6x, so I still only get positive 2x. So even switching the signs there doesn't help. So what if I actually switch the numbers? What if I put the 4 over here and the 2 over here instead, actually switching those terms? Well, now the outside product will be positive 2x. The inside product will be negative 12x. When I combine those, I get negative 10x, which is very close because I'm looking for positive 10x. To get a positive 10x is switch the sign. Instead of a negative 4 and a positive 2, I switch it to positive 4 and negative 2. Once I switch it to positive 4 and negative 2, then the outside product will give me negative 2x. The inside product will give me positive 12x. And when I combine those two, I get 10x. So when I FOIL this, x times 3x will give me 3x squared. X times negative 2 is negative 2x. 4 times 3x is 12x. Combining those gives me 10x. And 4 times negative 2 is negative 8. So it all works out. This is the correct factorization of that trinomial. Let's look at another example. So with this trinomial here, it's already in descending order of powers. So descending order of powers is not an issue. The GCF of 7, 12, and 5 is 1. And this last term doesn't have a variable. So the GCF of the trinomial is 1. So I'm looking for binomial factors. Alright, so the binomial factors I'll find by finding factors of the first term. Factors of the first term are x and 7x. I'll find factors of the last term. Factors of the last term are 1 and 5. And then I try to find all the combinations that could possibly give me this trinomial. So I'll try the x and the 7x like this with a positive 1 and a negative 5. I know they have to have opposite signs because the constant is negative. Whenever the constant is negative, the two last terms will have opposite signs. So once I put those in there, I'll try the outside product to get negative 5x, x times negative 5. The inside product will give me positive 7x, and 7x plus negative 5x gives me 2x, not negative 12x. So that doesn't work. All right, what if I switch the signs? Make it negative 1 and positive 5 instead. Well, in that case, the outside product will be 5x, the inside product will be negative 7x, and in that case, I get negative 2x instead, but not negative 12x, which is what I'm looking for. So that doesn't work. All right, so maybe if I switch the order, if I put the 5 in the first parenthesis and the negative 1 in the second parenthesis, in that case, I'll get negative x for the outside product, positive 35x for the inside product, and when I combine those, I get 34x, not negative 12x. So the last thing I can possibly try is to switch the signs, put a negative 5 and a positive 1 instead. If I put a negative 5 and a positive 1 instead, then the outside product is going to be x, just 1x. The inside product is negative 35x, and that gives me negative 34x, not negative 12x. So because I've tried every possible combination of these things, and none of them worked, this polynomial is a prime polynomial. So we say the final result here is that this is prime and cannot be factored into monomials and binomials. This is a prime trinomial. I can't find factors if I only use integer values for coefficients.